What's going on, everyone? Welcome back. I hope everybody's having a great day. Guys, today I got some NASA JPL space news clips. That's pretty much all this video is. Now, this is going to help anybody who doesn't know anything about some of these missions. It'll help them give them a little bit better understanding. And for anybody who's already seen them, it's kind of cool to watch anyway. The reason why I've done this is just to simply give you guys something to watch. However, the reason for this, and I want to give you my apologies for not making out a video this week. There's a good reason for it. I've been working on a video that may be actually the real smoking gun. That's right, guys. I think they might have made a little boo-boo in this particular, I'm going to just use the term photo because I don't want to give it away, right? So what I've been doing is compiling this day after day. Understand, I go to work and then I've been picking this thing apart and I've been taking each of these photos and then trying to examine them, enhance them, and put them aside for you guys. So it takes a little bit to put this photo together. I hope you understand that. So I think you guys are going to be pleasantly surprised and probably shocked at what you're going to see in this, because even I was like, wow, like total wow factor when it came to this, the stuff I've seen. And they might have done a little slip up, thankfully. So anyway, guys, without further ado, I'm going to let you guys watch this video, these NASA clips. And like I said, stay tuned for the next stuff. I'm going to try to have this out Friday night, if not, at least Saturday afternoon. So you guys will be able to watch it one way or the other, meaning before the weekend hangout. So anyway, guys, stay tuned for that. So guys, have yourself a great one. Sit back and relax for a little bit. Watch these video clips. And I'm going to see you in the next video.
We have ignition, and we have liftoff of the Titan Centaur, carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
They were launched in 1977. That's a long time ago. We say 41 years, but it's really two generations ago. You can think of what the technology was. Your smartphone has 200,000 times more memory than what the Voyager spacecraft have. And so it's just exciting that we've been able to get it into interstellar space.
We launched two Voyager spacecraft. They were basically the same, but they were on different paths. Voyager 2 was the one that was chosen to do the grand tour. That is, to fly by Jupiter, and then Saturn, and then Uranus, and then Neptune. And then after 1989, we began what is now called the Voyager Interstellar Mission. We were on a path we hoped to get to reach interstellar space while we still had power on the spacecraft to transmit the data back. And that's what Voyager 1 did in 2012, and that's now what Voyager 2 is starting to do in 2018. The sun creates this huge bubble of plasma, ionized material, goes outward at 1 million miles per hour and creates a bubble. And inside the bubble, most of the material has come from our sun, and the magnetic field has come from our sun. Outside the bubble, most of the material comes from other stars that exploded 5, 10, 15 million years ago. We have an instrument which measures the wind coming from the sun, and we saw that in fact there was no longer any measurable solar wind. We had left the bubble, basically.
The team has been looking forward for this for a long time and really working hard in an engineering sense to make this day happen and to keep the spacecraft with all the instruments on, so they could, all 5 instruments could sense the heliopause crossing and have data for that. What that means is that the Voyager 2 spacecraft is now traveling in interstellar space.
Well, this just contributes to the number of discoveries that Voyager has been making, and this is one we'd hoped we would have the chance to do, and fortunately, the SPOS spacecraft were still operating when they reached interstellar space. It's really quite remarkable. Voyager changed our view of the solar system, really. I mean, we saw these active volcanic activity on Io, we saw the possibility of ocean on Europa. Just time after time, we were discovering things that we had not really even imagined some years before the Voyager mission. What makes it so exciting is that not only do we confirm what we thought we knew, but even better, it tells us where we didn't know that there was something to be discovered.
Touchdown confirmed.
Hi, I'm Troy Lee Hudson. I am a member of the InSight Science team and the Instrument Systems Engineer for the HP Cubed. InSight is a mission to study the deep interior of Mars. It has many science instruments to do this, one of which is HP Cubed, a sort of planetary thermometer. A key component of HP Cubed is called the mole, sort of a self-hammering nail that drives its way into the ground. And when we first commanded it to do this penetration, it did so beautifully, but at a certain point, it stopped making forward progress. This is a full-scale model of the HP Cube's support structure. The mole started out in this vertical tube, and when we commanded the mole to start digging, it released and started making progress, millimeter by millimeter, into the ground. At a certain point, it began to tilt, and around here, approximately 10 centimeters above the surface of the ground, it stopped making progress. So at this point, we believe the mole is still partially within the support structure, pointing at about a 20-degree tilt to the southwest. It could be the case that the mole has encountered an external obstruction, like a rock. But another possibility is that the soil at InSight is providing us less friction than we expected, and the mole needs friction to make forward progress. JPL, working along with DLR, the German space agency who provided the mole, have been trying to understand what the problem is and come up with a plan of action. We can't get a clear picture of what's happening with the mole. The support structure is in the way, so we need to pick up the support structure and move it elsewhere. We've been practicing that lift here in the test bed with models of the arm and the support structure. The lift has to be done carefully in 3 stages, small moves, so we can look at the data and, among other things, ensure that we're not inadvertently extracting the mole. Once we move the support structure and get a clear view of what's going on with the mole, we want to use the robotic arm again to help it. Our first choice is to come in with the scoop on the robotic arm and press flat on the soil above the mole. This may increase the friction at the mole, giving it that extra nudge it needs to start making progress. This is unexplored territory. The mole is going somewhere we cannot see and have never been before. To get that crucial number, the heat flow of Mars. As a scientist, I want to get that number. And as an engineer, I want to see the instrument we've worked on for a decade do the thing it was designed to do.
Can we fly at Mars? That has been a question for a long time. This is a huge milestone for us. But really, our job isn't done until we see the same test flight being performed at Mars.
For almost 7 years, NASA's Curiosity rover has been exploring Mars. Let's see where it is now. The rover is climbing a mountain, Mount Sharp, that is dry and sandy today. But 3.5 billion years ago, rivers, lakes, and groundwater could be found here. The white line shows where we'd like to send Curiosity over the next few years. Curiosity recently entered a valley between a ridge and cliffs higher up the mountain. We've been calling this area the clay unit because Mars orbiters have seen a strong clay signal here. That's exciting because clay minerals often form when water is around. From the ground, we can look for clues of ancient water. In these cliffs above the clay unit, the same orbiters see sulfate minerals. That could mean that water was drying up or becoming more acidic. Comparing the clay and sulfate layers could give us a better idea of how the Martian climate changed over time. Cutting through the sulfate layer is evidence of an ancient gushing river, Geddes Vallis Channel. In orbiter images, we've seen boulders and other debris that were probably washed out by the river. This channel formed after the clay and sulfate layers. It's a whole other chapter in the story of water on Mount Sharp. These features could teach us about more than just the mountain. They may help explain what changes were happening across Mars at the same time, and how that affected its ability to support life, if it ever existed here.
Positive confirmation of a safe landing. We're seeing it on the LTP. Very strong on LTP.
Opportunity hit a hole-in-one when she landed. The airbag system rolled into the small crater called Eagle Crater. And when the rover first turned on its cameras, it saw that the rim of the small crater was lined with exposed bedrock.
So we took out our microscope for the first time and we took a picture, and the surface of Mars at that location is littered with an uncountable number of little round things.
That were called blueberries because they looked like blueberries in a muffin. What we discovered was that those are features that form in water, and they were a really definitive sign that there had been liquid water on the surface of Mars sometime in the past.
You know, after we left Eagle Crater, we went to Endurance Crater, and that's the crater we drove down in. And there we did what the geologists call an in-sequence stratigraphic section, which is essentially reading the chapters of the Martian history book in reverse order.
That rover became a stratigrapher. First time you had a stratigrapher on Mars. We knew we wanted to go after Endurance to Victoria.
We put pedal to the metal and we started heading there, tens of kilometers away. We had to literally surf across these dunes of wind-blown material, and the rover got stuck in one of those. We had to get the rover unstuck. What we found is the best way to get it out is just to put it in reverse and gun it. The rover eventually popped out. And so we changed our driving strategy. So we recognized these ripples as hazards. We get to this giant half-mile diameter crater, Victoria Crater, and we want to figure out, gee, how can we go into this thing?
All of a sudden we got high-rise images. We could see the rover in the image.
And that was the very first image that we got from space showing one of our rovers.
We spent a year scouting the edge of that crater to decide where we wanted to go in to get the best stratigraphic section.
We found a place to go in, and we drove down in, and we spent about a year inside Victoria Crater.
The science team was really excited about the idea of driving to Endeavour Crater, over 20 kilometers away. This is a long drive to do. It was going to take multiple years, but they decided to do it anyways.
There were too many of these dangerous ripples in our way, and we actually had to take this circuitous route that at times took us away from the crater, only to then cut back and then approach it more directly.
And then we pull up to Endeavour Crater, and all of a sudden there's all these new things to look at.
We first discovered the homestake vein. It was this very, very bright linear feature. It turns out that there was a big gypsum vein, and we see these gypsum veins now all over. So it was our first taste of what is a really important process on Mars.
We were driving to a valley, and along the way there we realized that right about the point where we were about to get to this valley, that was when we were going to cross the marathon mark. So we said, well, that's cool. We're just going to name this valley after that, call it Marathon Valley. That was when we reached the distance of a marathon, 26.2 miles on another planet. We continued driving through some slopes down a little bit on the interior of the crater rim until we came back out so that we could continue on to the next valley, Perseverance Valley,
where the rover was exploring when we lost contact.
We said we're going to operate this vehicle until the day where we can't, and that's exactly what we did, and I'm really proud.
We've set a foundation that will serve as the basis for future exploration.
You know, when you work on a mission this long, it feels like a part of you. I've been a space enthusiast since I was 4 years old. Getting to work on a mission like this it's a dream come true. To me, Dawn is truly Earth's first interplanetary spaceship. No other spacecraft has gone to a distant body, gone into orbit around it, maneuvered there, then broken out of orbit, traveled elsewhere in the solar system to another alien world, and gone into orbit around it. And it does that with ion propulsion, which I first heard of in a Star Trek episode. We've turned ion propulsion from science fiction into science fact.
The Dawn mission really is a journey back to the beginning of the solar system, and that's why we call it Dawn. We chose 2 time capsules from the beginning of the solar system, Vesta and Ceres, which are the most massive and largest bodies in the main asteroid belt. They both formed very early when the solar system was forming out of the protoplanetary disk, and yet they ended up in these 2 very different states. Vesta is a dry, rocky body that looks a lot like our moon, whereas Ceres had a lot of water, and it looks much more like the icy moons of the outer solar system.
And it seems like what determined their eventual fate was the location where they started. And we now believe that Ceres formed much farther from the sun than it is now.
When Dawn found the bright material on Ceres, what we saw was completely mind-blowing. It was made of sodium carbonate. Sodium carbonate is not common in the solar system, but we see it coming out of the plumes of Enceladus. We see it in lakes on Earth, and here it was on the surface of Ceres.
The mission will end when Dawn runs out of the conventional chemical propellant that it uses to orient itself in the zero gravity of space. Dawn will become this inert celestial monument in orbit around the dwarf planet that it unveiled. Dawn serves as a lasting reminder that the passion for bold adventures and our noble aspirations to reach out into the cosmos take us far, far beyond the confines of our humble home here on planet Earth.
It was a special day when this object was first discovered. We have been waiting for the discovery of an interstellar object for decades, basically.
Well, when I first heard about this interstellar object, it was very exciting just from a scientific point of view that finally there's been an actual observation of such an object.
This object is simply a piece of another solar system that was expelled, and it has been traveling through interstellar space for hundreds of millions of years, billions of years, we don't know.
A number of our survey projects and other observatories immediately turned their telescopes to take observations of this object. From the observations we have so far, it looks like it's a very elongated object, maybe about a quarter mile in length.
We think this object, 2017 U1, is very long, perhaps 400 meters or so long, and very narrow, skinny, perhaps maybe 40 meters or so in the other dimensions. That's a very unusual shape. We don't see that in our solar system. None of the asteroids in our solar system look like that. So it's very puzzling how it could have obtained this shape.
We also see that it's very reddish in color, which indicates that it's been possibly in space a long time and irradiated by not only the light from our sun, but other suns as well.
There's still quite a bit to learn about this interstellar object and limited time because it's on its way out of the solar system.
It's fading very fast. It's a relatively small object, so it's very dim. But we are continuing to try to use NASA assets like the Hubble Space Telescope and Spitzer to take observations to determine more about its size and composition.
NASA's Planetary Defense Coordination Office has a near-Earth object observations program which funds efforts that survey the skies to look for near-Earth asteroids and to calculate their orbits and their trajectories and to determine if any of them might pose a hazard to Earth. And as part of doing that, some amazing discoveries can happen, and the discovery of this interstellar object was one of them.
As our observational capabilities improve, Pan-STARRS has been getting better, other surveys have been getting better. There are a new generation surveys that will come online. We will be detecting more of these in the future.